So we're still in 2.1 and we're looking now at these rational equations. So rational equations is when an equation includes at least one variable in the denominator. So this one at the bottom, you can see is different than this one up here because it has the x in the denominator. The one at the top is a linear equation. So how are we going to solve this rational equation? Well, we're going to treat it in a similar fashion to what we did when we clear the fraction. But we do have to check if there's a restriction on the variable. Because when you have an x in the denominator, we learned in the last unit, if the x makes that denominator equal to 0, then that value can never be equal to that number. So we will take and set the denominator with the x equal to 0. So we've got two denominators with an x. So setting both of those equal to 0, divide both sides by 2 here, we get x equals 0. And divide both sides by 3 here, we get x equals 0. So we know there's a restriction that x cannot be 0. 0 is not in the domain of x. So if we went to solve this and we find out that our x is equal to 0, then we have to say there's no solution to this equation. So let's look at this one. Now, in order to clear the fractions, remember I told you need to multiply by the least common denominator. So if we were to multiply this by the least common denominator, then we have to find that, and we're going to use the table method to find it. All right, so here is our whiteboard, and so let's do our table method here. So looking at the problem, our denominators are 2x, 18, and 3x. So if I was to break this down into its prime factors, I have a 2 and I have an x. 18. 18 is made up of 3 times 6. 3 is a prime number. 6 is not. So there's a 2 in there. There is no x's, but there's a 3. And 3x does not have a 2. It does have an x, and it has a 3. So if I was to look for the least common multiple, or least common denominator, it's going to be made up, each column, take the highest amount. So the highest amount of factors of 2 is 1. The highest amount of factors of x is 1. The highest amount of factors of 3 is 1. Actually, I made an error here. There are 2 3's here. So let's put that. The 18 is made up of 2 times 3 times 3. So when I write it down here, it would be 2 times x times 3 times 3. So the highest amount of each column. And so that will give me 18x. So this is what I'm going to multiply everything by. So let's go back to our paper. And so we will multiply everything by 18x. Now remember, what is the goal here? The goal is to clear the denominator. So if you're multiplying by a number and it doesn't get rid of the denominator, then, or the whole denominator, only part of it, then you've probably chose the incorrect least common denominator to multiply by. So I'm going to have 18x in 3 spots here. And it will look like this. And so what's going to simplify here? Well, the x's will divide out. 2 goes into 18 9 tenths. This term, the 18's divide out. And in this term, the x's divide out, and 3 goes into 18 6 times. So what am I left with? So I'm just going to write the factors that I'm left with, which are 9 times 5, 17 times x, and then 1 times 6. So I'll get 45 is equal to 17x minus 6. This is a much nicer equation to solve than what this looks like, right? So now, how am I going to solve this? Well, I'm going to solve it by isolating this x. And I isolate it by saying this is minus 6. I'm going to add 6 to both sides. When I add 6 to both sides, I will get 51 is equal to 17x. And then I will divide both sides by 17. I will end up with, this will divide out, and I'll end up with 3 is equal to x. So, filling in the blanks here, the least common denominator is 18x. We multiply both sides by 18x. And here I can just write this down here instead of putting it off to the side. And then that will give me room to do a check, because I want to check this proposed solution in my original. My original was 5 over 2x minus 17, or equals 17 over 18 minus 1 over 3x. So in place of the x, I'm going to plug in 3. And so I'm going to just put this in the calculator, but this will be 5 over 6 is equal to 17 over 18 minus 1 over 9. Now I could find common fractions, common denominators, make equivalent fractions, and then do that, but it's not necessary. We have the calculator, we have access to the calculator. We're just doing a check on it, so we're going to check it with the calculator. Now let's pull the calculator over and let's do that check. So, let's see here. 5 over 6 is the left side. So this left side is 0.83 run on 3. And then I'll say 17 over 18 minus 1 over 9. And I get 0.83 for both sides. So since I got 0.83 for both sides, I know that this is true. This makes it a true statement. So then my proposed solution is the correct solution. So this is a problem similar to one that you're going to see in the MyLab math. And let's look at how we would approach this one. It's similar to the one we just did. So what I would suggest you do is you try this one on your own, pause the video, try it on your own, and then come back to the video and watch how I do it. All right, so now we're back to the video, and let's take a look. The first thing we need to do is, first we can talk about the restrictions, and then we're going to create a table. So the restrictions here, we have 2 denominators with x's in them. And so I'm going to set this one equal to 0, I get 11. And then I'm going to take the other one, set it equal to 0, and I get 0. And I think I said 11 here, I meant 0. So I wrote 0, but I said 11. All right, so dividing both sides by 11, you get 0. Dividing both sides here by 22, you get 0. So there's a restriction that you cannot have 0 as your answer. So I'm going to say restriction, the value of x cannot be equal to 0. So when we get our answer, as long as it's not 0, then it's fine. So plugging in the denominators here, we have 11x, 4, 22x, and 3. So 4 denominators this time. And if I had to write these numbers out, I would be writing out like the multiples of these. It'd probably take me a long time to write out to the number I need to get to. So this is where the table comes in handy. So 11x. 11 is a prime number. I've got a factor of 11 and an x in this one. 4. Well, 4 does not have 11 in it, and it doesn't have x in it. But 4 is made up of 2 times 2. How about 22? Well, 22 is not prime. It's made up of 2 times 22, or 2 times 2. So 11 times 2. And then also x. So it's made, I'm sorry if I said that wrong. It's 22x. It's made up of 11 times 2 times x. So 22 is not prime. It's made up of 2 times 11. And then we have the x there too. And then lastly, we have 3, which is a prime number. Does not have any of these factors, but it has its own factor to introduce. And so I'll put dashes where there are no factors. Then I go through and I pick each column. And I'm going to take the highest amount in each column. And that will make up my least common multiple. And so I've got 11. I've got x, 2 times 2, and 3. So 11 times x times 2 times 2 times 3. Put that in the calculator. Let's see what we get. $132. So my least common multiple would be 132x. So I'm going to take that now, and I'm going to multiply everything by 132. So we'll take it up here, and we're going to say multiply everything by 132x. So let's give ourselves some room. And so the 132x is going to go in 4 places. And it'll be 132x times 2 over 11x. And it'll be 132x times 1 over 4. It'll be 132x times 81 over 22x. And it'll be 132x times 1 over 3. So now let's do some simplifying and factoring out. So, and I have to keep in mind that I can use the calculator to help me here. Because these are larger numbers that I'm not familiar with when factoring out. The x's factor out here. But what about 132 divided by 11? What is that? It should work out to a whole number. Because if I pick the right multiple of it, of the denominator, it will. So I get 12. So 11 goes into 132 12 times. 4, so the x remains, but 4 goes into 132. Let's see how many times. 33 times. The x's divide out here. 22 goes into 132. Let's see how many times. 6 times. And the last one, 132 divided by 3 would be 44. So let's write those down here. So we've got 6 and we've got 44. So what's left, we've got 12 times 2. We have 33 times 1. I'm sorry, 33x. So the x is not crossed out there. So 33x times 1. Then we have 6 times 81. And then lastly, we have 44x times 1. And let's not forget the minus sign here. So I'm going to end up with 24 plus 33x. 6 times 81. Put it in the calculator. It's 486. 44 times 1 is 44. And then the x. Now, this problem, much nicer looking than up above. We got to put all our x's on one side, put all your numbers on the other side. So what are we going to end up with? Well, I end up with 77x is equal to 486. Subtract 24 from both sides. You're going to end up with 77x is equal to 462. Divide both sides by 77 to get x equals 6. That's my answer here. And then I would check it with the calculator.